Hi, my name is William Farr, and I will be the team lead for the project Malware Analysis using reverse engineering. The team members are Isa Strong, Michael Lewis, and Calvin Reed. Affiliation is Kennesaw State University. Our project sponsor is Hussein Shahir. Our project identifier is 30, and our project website will be hosted at studentweb.kennesaw.edu. And this is our project abstract. Essentially, our project is we will be looking at how malware eludes detection. We'll be reverse engineering it using IDA Pro and WinDebugger. And then we will be creating a set of security policies to better help a company protect themselves from infections. And then we will also be providing a set of a documentation on how someone should secure a virtual machine. How malware eludes detection. We have stalling delays. This is where malware remains idle to defeat timer-based recognition. And we have action required delays. This is where malware uses delay tactics where a user must perform a certain action before the malware will execute itself. Intelligent suspension. This is where malware basically waits until it has it's infected the host machine before it will do any injecting or modifying any files. Fragmentation. This is where the malware splits into multiple separate fragments, and the sandbox will go ahead and it will analyze each fragment, and it will say that the fragment itself is not malicious, and then once it comes back together and reassembles, it will execute. We have rootkits, which is hiding malicious code at the fundamentals of the operating system. We have social engineering, which is using people's basically weaknesses against them to help infect themselves with malware. And then we have phishing attacks, which is another example of social engineering, which is where you're sending them emails that are designed to look from someone else or designed to look from a company that you can trust when really it is just a hacker sending these. And then we have the current malware detection tools effective. We use the EICAR.com test virus to do this, and we tested AVG antivirus, Malwarebytes, and Windows Defender. We essentially just downloaded this test malware onto our system, and we tested to see if AVG, Malwarebytes, and Windows Defender were able to detect them. All of them were able to detect it, and all of them were able to say that it was malicious. Security policies, we basically have just a couple of social engineering and phishing attack training. Basically, everyone needs to be trained on social engineering attacks and phishing attacks and how to stop against them. You need to encrypt files and folders containing sensitive information. We have to clearly define acceptable use of company computers, including what website, software, and hardware applications they can use. Clearly define a password security policy, multi-factor authentication, email retention policies. Data breach response is huge. Having a disaster recovery plan in place. Never connect unknown or unauthorized devices to a work machine. Encrypt all external drives. Wipe and destroy storage devices when they are no longer in use. Never have any hard drive, anything that has any sort of sensitive data. It should not be able to be used if it's going out of your company. Only connect to PCs that are secure and authorized networks. Never go to like a public network and connect your work computer. Extend and change sleep duration to defeat timer-based malware techniques. Simulate human interactions such as clicking and scrolling, and add real hardware information to the malware. And then malware analysis. You can see here that during this command, you are actually having the data from practical malware analysis is being moved into the EXE from address 1001940. And this is basically making a DNS request for pic.practicalmalwareanalysis.com. You can see that this has a cmd.exe-c and the disassembly, and this is basically telling us that this malware is trying to start a shell command and attempting to run it on there. And then you see towards the end it says encrypt magic number for this remote shell connection. So we can actually confirm from the previous slide that they are actually attempting to make a remote shell connection on this device. We can see that this malware is injecting itself and idling to, it's injecting data and then it's idling to help avoid being detected. And then we can see this function right here in the malware. This function is actually asking for the operating system of the host machine. And then if you look at the PS list and this piece of example malware, you can actually see that based off of the function sub 100036C3, the malware will actually take a different path based off of what this function reads back to it. And that is actually the function that is asking for the get operating system or get the operating system. So based on which operating system that this computer has, the malware will take a completely different approach. And then how to secure a virtual machine. You're going to want to download VirtualBox. You're going to want to get the registry key from the lab manager. And then when you're setting up your malware, you're going to want to use minimum 2 gigabytes of RAM, preferably 4 gigabytes. You're going to want to download everyday applications that malware would be checking to see if this is a virtual machine or not. You're going to want to delete any third-party VirtualBox, any tools that they've downloaded on there. You're going to want to use the bridge networked adapter, and you're going to want to make sure host client copy is disabled. And you're going to need to disable Windows Defender and Windows Firewall to download the malware. And then once you have properly downloaded the malware, you're going to want to switch your network connection to not attached. You're going to want to deny any connections to your computer, and you're going to want to disable the cable connection.